So we just have one more chapter?
Two more chapters. Well, the first lesson was on one chapter because that chain rule is quite different from what from the other two. The other one is just apply the formula and then just get it. It's not that hard. So the first one is called the product rule. The reason why I'm teaching all these three rules is because what's difficult is not learning the rule. What's difficult is recognizing which rule to use in the exam. Okay, that's the difficult part. If you use the wrong one, GG. So that's why I want to go through the main rules all one first, and then I have to jump around the rules. It will be difficult for you guys, but that's what the exam is going to be like. They will throw you a question and you're like, what rule is this? Is that the chain rule or is that what we're learning next, which is the product rule? Okay, skip. All right. Chain rule, product rule, or quotient rule. So those are the three main rules that you guys will learn in Unit 2, and they will be used again and again and again in Unit 3. So they will revisit these rules in Unit 3, but then in Unit 3 you need to learn how to derive like a lot more functions. So the better you are at these rules right now, the easier it will be for Unit 3 when you get to these rules again. Okay, so this is rule number 2 out of the series of 3 rules that we'll learn today. So the first one you guys learned was chain rule, which is when you have a function of a function, right? F of gx, right? And then this is the product rule. What do you guys think the last rule is called? Something rule.
Quotient.
Yes, that's right. If there's a product rule, there is a quotient rule. Okay? Okay, so product rule is when you have a function multiplied by another function. Okay, so it's not a function in a function, yeah? So see how chain rule is the only one that's different. It's a function in a function. Product is obvious, right? It's times, yeah? So a function times a function. Quotient rule, you see later, is a function divided by a function. Okay? Product rule, quotient rule, straightforward. Now, the product rule, let's just say if you have fx equals to, instead of writing it as function of some function, right? There is an easier way to write it as u times v. Okay? Where u is a function of fx, and v is another function gx. Okay? So then, what's the derivative? If fx is u times v, the derivative is going to be u dash v, and then plus u v dash. Okay, so note that u dash means the derivative of u, right? So this is the derivative of u, okay? And so v dash is the derivative of v, vice versa, right? But basically this is a rule that you guys have to remember. That's it, that's literally the product rule. It's not hard. Now, however, you need to remember, you always derive u first. Okay, this is very, very important. You always derive u first. Derive u first.
So derive the thing that's first, the product that's first?
Yeah, the first function, yeah. Because it's always u times v. So remember, in the alphabet, STUV, right? U comes before v. Yeah? So u always comes before v, u always get derived before v. Okay? The reason why this is important is later in the quotient rule. It's very similar to the product rule, but if you mess it up, it's going to be a challenge. Actually, maybe I'll just tell you the quotient rule now and then we'll test it out later. So this is the product rule, right? And then the quotient rule is when you have f of x equals to u over v. So remember, you read left to right, top to bottom. So u times v, u over v. Okay, so u is always the one that you see first, that you read first, right? So if this is this is u over v, f dash of x, the derivative, the rule is you always derive u first. Okay, you always derive u first. U dash v minus. So the quotient rule is a bit different. Minus u v dash over v squared. So as you can see, the quotient rule is a little bit more involved, right? It looks similar to the product rule. However, product rule is a plus between these two. Quotient rule is a minus. And then you also have to divide by v squared. Okay? All right? So that's the difference between product and quotient rule. So this is the this is specifically for the quotient rule. We will do that in the next chapter, but for now we'll practice on the product rule first. Okay, I will use an example of number 14. So example 14, fx is equals to x squared plus 3x and then times by 4x plus 5. Okay, so note that when you see brackets like that, if there's nothing between them, it's times. Okay, I have to remind everyone this, and sometimes people forget. Okay, that means that u is equals to x squared plus 3x, right? That's the first one, and I like to write v next to it. V equals to 4x plus 5, like so. Okay, make sense? Yeah, so it follows in the same order. That's u and that's v. So it follows the same order. Why do I write it side by side? Well, you see later. So next I would derive u and then derive v. Okay, because in the formula is u dash v times uv dash, right? So you derive u, that would be 2x plus 3, right? And then derive v is 4. Make sense? Yeah? So then the derivative f dash of x, once you've done this step there, the rest is easy. Is equals to, just write the formula again, u dash v times, plus u v dash. And when you look at that, u dash v is always start from here and then you times across, right? And then u v dash is this one here. So it always gets multiplied across. Make sense? Yeah. So the short notation of this is I normally do that. Just to remind myself that u dash links to v and u links to v dash. Okay? So you derive u first. So u dash v is, put everything in brackets if it's more than one term. 2x plus 3 times by 4x plus 5 and then plus u, which is x squared plus 3x times v dash, which is 4. Okay? So looking at this equation here, do you guys think we can simplify it?
Yeah.
Yeah, right? Why? How do you know that we can simplify that after expanding it?
Because there's lots of something x's.
Yes, yeah, there are lots of something x's, but the key here is look at the highest power. When you multiply these two, you get x squared. Right? Make sense? Like 8x squared, right? That's the highest power when you expand. What's the highest power on the other one? Also x squared. That means you can combine them if you expand the brackets. Okay, so only if you can expand the brackets and then simplify it, then you have to expand the brackets. So that'll be 8x squared. Just make sure you do distributive property here. Okay, plus 10x plus 12x plus 15. And then times the 4 distributively into this one. That'll be plus x squared, 4x squared plus 12x. Add the x squared term together and then all the x terms together. Then I would get 12x squared, 10, 12, 12 is 24, 34 plus 15. And that is the final answer. Any question?
I'm just processing it.
Well, best way to process this is redo the question.
What?
Go, example 14. Yes, any question?
No, I'm just thinking.
Yeah, retry this example. So retry it without looking at my answer if you can.
Okay.
Okay, so if you can do example 14, you can move on to question 1. But yeah, redo example 14 first, so you see, redo something that you've seen the answer for, and try to reproduce the exact same answer for now if you can. Alright. Alright, I will start working through question 1. Hi, what question are you on now, Blake?
1B.
1B, okay. Sarah?
1B.
1B, okay.
In question 1D, do you expand the brackets first?
You can, or you can just, so when you derive, remember any constant number, you can ignore it, derive what's in the bracket. So when you derive this, you just get 1.
Okay.
Alright, but you can expand it first. That will make things a little bit easier.
So, and then I just derive what I've expanded,
Mm-hmm.
which is 2.
Okay, if you're done with question 1, I want you guys to move on to question 3. Now, the question, so let me pause there. Let me quickly explain question 3 to you guys, right? And then see if you can identify the easiest way to do it. So question 3 is a little bit different. I will work through these questions, but you need to predict, expect or predict what method I'll use. So the keyword here is differentiate, yes, and then only use the product rule if it is the simplest method. If you can think of a simpler method to use to do, then you can do that instead. Okay. Some of these questions, it will be easier to not use product rule, and some will be easier to use the product rule. Actually, hang on, let me see. No, actually, these questions, okay, it's strange that they phrase it this way, but for these questions, right, I would not use the product rule. But why? Would I use the product rule in question B?
No.
No, because when you can easily expand it, right? That would be 12x cubed plus 15x squared, right? And then when you derive it, it's easy. There's no product rule, there's no u and v. You can even derive it straight away, right? So if this is the one, then d over dx would be just 36x squared plus 30x, right? You can do that in one line. Okay, so these questions, many of these ones, you won't need product rule, but why? What's the difference between these questions and let's say, even technically these ones you don't need to use product rule either if you want to expand it. But what's the difference between these questions versus a question that looks something like this? What's the difference? Would you use product rule on this, or would you expand?
Because there are like two terms in brackets.
Well, technically there are two brackets. This one you can.
outside term?
Sorry.
Is it the outside term?
What do you mean by outside?
factor, the power 3.
Yes, it's because this one is to the power of 3. Alright? But look at this. Linear power, power 1. The brackets here, power 1, power 1, power 1, power 1. There's no power on these brackets. So if you want, you can even just expand it. Just do expansion, because if you use a product rule, you will have to expand it anyway. So if the power of the bracket is just 1, you can just expand it. Right? And then differentiate. Only when you have something like power 3, wow, this one you don't want to expand the power 3 brackets, right? Do you? If you don't want to expand this one, then that's when you use the product rule. So you will see this kind of question later. It's actually a chain rule in a product rule.
So it'd be 3 times 3x plus 1 squared, and then you do the chain thing.
Yes, you do the chain thing. Very good. This is a chain rule in a product rule. Pretty sure you will see that later in question 4. So yeah, so for question 3, don't even bother with the product rule, just expand it. Okay, so just quickly do that, and then when you go to question 4, that's when you actually have to use the product rule.
Would you just be able to go up to 1t? Would you please be able to go up to 1d?
Yep.
So what does just expanding the brackets do?
You just turn them into terms, not product. Not a product of two functions.
And
You just derive each term one by one when you derive it.
And what would you do with these terms?
Derive it. So the main question is differentiate, right? Yeah, so once you expand it, you can just, just go d over dx.
Wait, how did you go from the second line to the d over to dx?
Differentiate. Yeah, it's just differentiating this, you get that. You differentiate this, you get that.
Oh, yeah.
Yeah, the main question is differentiate. Yeah, this chapter is all about derivative. Chapter 10, 18, 19, 20 is all about calculus derivative. So you are deriving this equation. Just that when you expand it first, you don't have to use the product rule. right? So you see the confusion is slower to set in. It's like, what do we do with this, right?
Yeah.
When you use the product rule, that's also differentiating. It's just using the product rule to differentiate. So in the exam, you need to know which rule to use and where. Learning the rules is not hard, but applying them in an exam condition, that's hard. That's why having a whole term to practice may or may not be enough. Hopefully it will be, but we'll see. Any question for me, Sarah? Which question are you on now?
I just finished 1D, but I was accidentally looking at 1B, so I already did the
That's fine. Just move on to question 3 for now, okay? You get a chance to do more of these questions later. So yeah, move on to 3, and then after 3 will be 4.
In question 3D, can we just simplify?
How?
Like negative 4x plus 4x cancel out?
Yeah. But if better, if you can recognize it as the difference of two perfect squares.
Yeah.
Yeah.
Why have you just left question 3E? Is that all you can do?
Oh no, not yet. I haven't done that yet. I was just writing out the other question to expand.
Yeah.
But yes, you can. Yeah, of course you
10 to
can.
the power x should be, shouldn't it?
Yeah, you should be able to. Yeah, E is a simple one. Yeah, I just wrote the extra, like the bits in gray is the how to get to the textbook answer. But normally when you get to the boxed up answer, it's accepted already. Okay, that's all question 3. Now, question 4 is the main one that you guys need to focus on practicing. Question 4 is the one where you will have to use the product rule, and then there will be a chain rule in the product rule. And that's where it's handy to use that quick notation I told you before, the function notation. Now, what question are you on now, Blake?
Question F.
Question F, okay. Sarah?
3C.
3C, okay. So finish what you guys are moving, what you guys are working on, C for Blake and F for Sarah, move on to question 4. Okay, these questions not hard, it's just a lot of algebra. So finish that one, move on to question 4. You guys can do the rest of the question later at home, you have the answers.
How did you go?
That's it.
Yeah.
Yeah, combine these two. 8x squared minus 4x squared is 4x squared. Right? Like terms.
Oh, but I did that and then.
The same thing, yeah.
But it's.
But then when you differentiate that with 0. Yeah. Okay, so finish whatever you guys are on and then move on to question 4. Question 4 is the main one. This one is the important one for practicing. Yeah, this one actually uses the chain rule. Question 3 was not really about chain rule. This one is. Now, any questions, Sarah? Did you guys see right? Yep. Okay. Question 4.
Don't you just do the same thing once you move it to the front?
Well, what do you mean by the same thing?
Because I moved the power to made it to x take 1, and then can I make that my u?
You mean this one?
Yeah, so 2x take 1 to the power of 1.
2x takes 1 to the power of 1? You mean this one, right? That's the derivative already.
Oh, yeah.
Yeah. So yes, that is what you need to get to, yes. But that's already the derivative.
So when do you use the chain rule?
It's in that one. That one, you just use the chain rule. It's 2 times x take 1 power 1 and then times it by 1, right? Because when you derive x minus 1, you get 1 plus 0. So technically it's this. Okay, so for example, question B is the one that might be a bit tricky. So question B is the one where when you derive it, you don't get 0 in the brackets. So in order for question A, I'm taking out a common factor. Yeah, actually I'll take out even the 2 and the common. Yeah, I'll take out the common factor so that in the brackets is a lot more simple.
Can't you cancel out the 2's?
What do you mean by cancel out the 2's? You're taking that out as a common factor, not cancelling it out. Alright, because this in this step there are 2 terms, and this is this whole thing could be a factor, right? And then the other one, when you take out 2 and then 1 of the x minus 1, you're left with 1 of the x minus 1. Yeah. Okay, as I said, question 4 is the one that you actually need to focus on practicing. Any questions, Sarah?
Did you like expand the square and put it back?
On this step?
Yeah.
So this step is, I took out the common factor, so there are 2 terms, right? And this one is technically, so this one can be thought of as 2 times x minus 1 times x minus 1, right? And so the common factor is this. So when you take out the blue highlighted bits from the 2 expressions, you're left with what's what's left behind, which is this one there and then this one there. Oh, well, technically that one.
Please go to the bathroom.
Yeah. Did you finish A, Sarah?
Do you like after the like 2x plus 3 plus x minus 1, do you just combine it and then find
Yeah. You mean, okay, is your question around how to go from this line to this line, or is it from this line to this line?
yeah.
Yeah, this one, right? Yeah, so from here to here, it's just expanding the brackets. Alright, so 2x plus 3, there's nothing in front of it, so when you expand the bracket, it's the same. And then x minus 1 also doesn't have anything in front of it, so it will just stay the same. And then after that, just combining. Alright, 2x plus x is 3x, and 3 minus 1 is 2.
Is that all for question B?
Yep. So when you have like a chain rule in a product rule, that's when it gets longer. Similar to chain rule in a quotient rule. Okay, so the ones you guys need to focus on will be A, B, D, and E. Oh, actually E and F. A, B, E, and F. Okay, so after I let you guys work for a bit, I will start on working for E and F. It's a lot of algebra, but after you guys have done 2 or 3 questions, you see that it's quite similar. So apply the formula, take out common factors, and simplify. Okay, you done with B, Blake?
Not yet.
Not yet? Okay. Sarah, you're on B still? Okay. Finish B and then move on to E and F. Okay, I'll start working through question E and F now. Any question?
How did you, for the second last line of B, did you just expand using the distributive law or?
Second last line?
Yeah.
This one, right?
Yeah.
Just combine like terms. Right? And then, yeah, and yes, it's distributive law, so it'll be like 4 times x, 4 times 5, and then this one will just be the same.
No, I've got that line. How did you get to the answer?
To the answer is, oh, you mean from here to here,
Yeah.
right?
Oh, you divided by 3. Yeah. Okay.
Well, take out common factor 3.
Yeah.
Yeah. Right, so taking out common factor is a very common operation. You do that like a million times from now to the end of next year. Be very careful with E, right? The algebra is quite tricky. Take your time.
How did you get the derivative of u?
Just derive u each term 1 by 1. 2x becomes x squared. Sorry, x squared becomes 2x and 1 becomes 0.
Yeah.
Yeah, v is the one that's tricky because it has a funny fractional power. Alright, answer for E is up. Okay, it's a little bit tricky. The algebra is a bit tricky. Any question?
How did you make them the same denominator?
Times this one by square root of 2x.
But don't you have to do that to the other side as well?
No, the other one is already has that denominator.
So how can you just give it that?
So what happens here is this one will be over 1, right?
Mm-hmm.
And then I times this by square root of that and times the top by square root of that.
Okay. Oh yeah.
Yeah? And the other one already has the square root 2x minus 4 at the bottom. So the only thing that changes is this bit here. What question are you guys on?
The last one.
F?
Yeah.
Sarah?
But how did you, for E, how did you get 2x minus 4 in brackets?
In brackets without the square root? You mean? Like this one then? Yeah, because when you times the top and bottom by square root, right? The two square root will cancel each other out. See? So when you times square root, the answer will just be that number. It's like root 2 times root 2 is just 2. So F will be the last one.
How did you get the derivative of u? 3x squared.
U is just x cubed. So when you derive it, it's 3 times x dropped the power by 1.
Oh yeah.
Yeah, when you start learning more rules, you start to forget some rules. Boy, we'll do a recap on these topics next week. Okay, well, you guys are both on F, right?
Yeah.
Okay, quickly finish that because I want to jump to quotient rule first. And make sure you bring these sheets next week, yeah? Because we will come back to these next week. There are more questions I want you guys to do. Alright, Charlie, if you're listening to the recording at this point, I just finished question C, and we'll go through quotient rule in the next lesson instead. So just go back and practice these ones. I'll stop the recording now.